Chapter 11, Number 7. At the local playground, a 21-kilogram child sits on the right end of a horizontal teeter-totter 1.8 meters from the pivot point. On the left side of the pivot, an adult pushes straight down on the teeter-totter with a force of 151 newtons. In which direction does the teeter-totter rotate if the adult applies the force from a distance of either 3 or 2.5 or 2 meters from the pivot? So that's our situation. We know that the child puts a torque, which is the weight of the child times the distance the child is from the pivot. So that's going to be 21 kilograms times 9.81 meters per second square times 1.8 meters, or 370.818 Newton meters. What we'd like to know then is how far away would the other force, F, have to be so as to produce balance. So we can say they would be balanced if F times L equals Fg times S, or in other words, if L were the torque we just computed divided by the 151 newtons, which turns out to be 2.456 meters. So that tells us that if the distance is greater than 2.456 meters, the torque due to the adult will be more than the torque due to the child. So if our distance is greater than 2.456, then it will rotate counterclockwise. If it's equal to that, it won't rotate at all. And if it's less than that, the child's weight will outdo the torque and it will rotate the other way. So we can say that in A, and looking very quickly, A, B, and C, we get anti-clockwise rotation in A, and we get clockwise rotation in C. B is interesting because we have only 2 sig figs. Therefore, this really should be 2.5. And so this would be essentially no rotation, although our calculations indicate maybe a very slight anti-clockwise rotation.